Okay, we're going to start talking about units of energy. We just discussed last week the different types of energy. Energy is something that can be measured, so we need units for it. So the SI unit, or the metric unit for energy, is the joule, and that's one that we use in chemistry quite a bit. Joule, pronounced like a jewel, like a gemstone or something. It's named after a guy whose last name was Joule. Another unit that's going to sound a lot more familiar is the calorie. Joule is abbreviated capital J. Calorie is abbreviated lowercase cal. And they defined the unit calorie in a very particular way. It's the amount of energy needed to raise the temperature of 1 gram of water by 1 degree Celsius. The calorie is a slightly larger unit than the joule. The relationship here is that 1 calorie equals 4.184 joules. I would recommend that you kind of keep that one in your head. I'll put it on an exam somewhere, but we're going to use that one fairly frequently, and so that's one that's worth memorizing. Now, the calories that we talk about in everyday life, that has, 260 calories in a can of soda or something. Those are dietary or nutritional calories, and those have a capital C. So the abbreviation is capital CAL. We don't use those in science, but they're related to the lowercase calorie that we do use, and so we need to know what they are. And that is equivalent to a kilocalorie. It's a big calorie. It's got a big C. It's 1,000 calories. Another unit that you may have come across is kilowatt hours. That's what the electric company measures your electricity in. That's a unit of energy also, but we don't use that in science. Not in chemistry, anyway. So here's a table from your book giving the relationships. It's not a super useful table, doesn't have a lot in there, but you might need to refer to that in doing some problems like this one. Okay, so here's an example of a unit conversion with energy units. We're going to use the same dimensional analysis technique. We've just got some new units that we've thrown in here. So the complete combustion of a small wooden match produces approximately 512 calories of heat. How many kilojoules are produced? So again, we're going to figure out where we're starting, where we're going, how we're going to get there. So this problem is fairly simple. It just gives us one number. So that number is probably going to be important. 512 calories. And what do they ask us to find? Kilojoules. Okay, that's that question right there. How many kilojoules are produced? So we're starting with 512 calories, and we're ending up with kilojoules. And so we have to figure out, do we need multiple steps? Can we go directly from calories to kilojoules? Well, if all we have at hand is that table on the previous slide, there was a relationship between joules and calories. Remember, 1 calorie equals 4.184 joules. So we could go from calories to joules using that relationship. Could we go from joules to kilojoules? Yeah, because we learned those metric unit prefixes and how to use them, and we can apply them to any unit. So we can go from joules to kilojoules. So now we've got our path laid out, calories to joules to kilojoules. So now we write out our equation, 512 calories, and that has 2 arrows, so we're going to have 2 fractions. And calories to joules to kilojoules, calories to joules to kilojoules. Okay, and then the previous unit becomes the denominator. The joules are going to cancel out. The calories are going to cancel out. Dimensional analysis is telling us what to do because of the units. We need the relationship between calories and joules. We looked that up. It's 1 calorie for 4, decimal point got lost, 0.184 joules. I'm testing out this stylus. I'm not sure if I like it. I think my finger's better. Okay, so that one we looked up. Kilojoules to joules, we ask ourselves, what does kilo mean? Kilo means 10 to the positive 3. 10 to the 3. or 1,000. If you want to write 1,000 in there, that's fine. And so there we have our setup. And so then we get out our calculator. 512 times 4.184 divided by 1E3 equals. The calculator is showing me 2.142208. How many significant figures should I have? 3. Because up here, the number we started with had 3 significant figures. This conversion factor has 4 significant figures, 4.184, and this conversion is exact. So 3 is the smallest number and is going to limit our significant figures in the answer. So I'm going to write that as 2.14 kilojoules. Okay, any questions? So same process, we're just throwing some new units in there.